Alright, this video is going to be part 1 of our ratio test practice. Okay, so we want to prove whether the series converges or diverges using the ratio test, and our series is right up on the board here. The sum from n equals 1 to infinity of n times 3/4 to the n power. Okay, so using the ratio test, what is the ratio test format? Well, we need to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Okay? Now, a sub n plus 1. Let's figure what that is going to be. Take the limit as n approaches infinity of, it's going to be, instead of n, we're going to have n plus 1. Okay? So we'll have n plus 1 times a 3/4 to the n plus 1. So we'll have a 3/4 to the n plus 1. And that's going to be over just a sub n, so just this. Okay? And that's just going to be n times 3/4 times n. Alright, now, what can we end up doing with this? Well, we're still going to have an n plus 1 over n. Alright? So we'll still have that n plus 1 over n. I guess I'll take it back this way. Limit as n approaches infinity of, and we actually don't need the absolute value signs because everything is positive inside here, so no sense in having those absolute value signs in there. We have an n plus 1 over n, and that's going to be multiplied by a, well, we just have a 3/4 to the n plus 1 over 3/4 to the n. We can use our exponent properties. The n's go away, and you're just left with 3/4 to the first power. Okay, just a little bit of subtraction there. So we just have a times 3/4. Okay, so now what we can do is we can distribute this 3 and the 4. Okay, and then it just becomes a regular limit. The limit as n approaches infinity of 3n plus 3 over 4n. Of course, you can divide everything by n here. You can use L'Hopital, whatever you'd like to do, and you end up with this limit equaling 3/4. Okay, now 3/4, that is less than 1, and that means that this series is absolutely convergent by the ratio test. Okay, so it's absolutely convergent, and this is asking, and you'll have some questions that are asking just for convergence or divergence. Okay, and saying it's absolutely convergent is not the same thing as saying it's convergent. Although, since it's absolutely convergent, that means that it's convergent. Okay, you need to say that though. So absolutely convergent and therefore convergent by the ratio test. Alright, so we have our next series up on the board here, the sum from n equals 1 to infinity of -3 to the n plus 1 over n factorial. Okay, so using the ratio test here, let's set up that limit. We have the limit as n approaches infinity of, well, this is going to be a -3 to, now this is going to be, and we're going to substitute in an n plus 1 for the n, okay, and that's going to be plus 1, so it's n plus 2, right? So -3 to the n plus 2 over, this will now be n plus 1 factorial. That's going to be over, now you're just going to have your a sub n, right? So that's just going to be -3 to the n plus 1 over n factorial, right? -3 to the n plus 1 over n factorial. Okay? Now, what we can do here is put everything into one fraction. Okay, so we don't have like two fractions here. That's annoying. The limit as n approaches infinity of, this is going to be a -3 to the n plus 2 over a -3 to the n plus 1. I like to separate it like this, just kind of makes it look a little nicer. And you also have here a n factorial over n plus 1 factorial. So n factorial over n plus 1 factorial. Okay, we're not going to take away the absolute value signs just yet because we do have negatives inside and we just don't want to, keep those at all. So we have the limit as n approaches infinity of, well, we have a n plus 2 minus n plus 1. that's just going to give us a 1, right? So we end up with negative 3 to the first power, okay? So we get negative 3 to the first power, so that's a negative 3, okay? And we can eliminate those absolute value signs and just make it a 3, okay? So now the absolute value signs aren't needed anymore because all this factorial stuff, it's all positive. Okay, now we have an n factorial over n plus 1 factorial. Now remember what I said about when I said in the last video about 5 factorial versus 6 factorial, okay? 6 factorial equals 6 times 5 factorial. Okay, so that means that n plus 1 factorial equals n plus 1 times n factorial. Okay, that's literally the same exact thing. If I just plug in 5 for n here, that's this. Okay, so with that in mind, n factorial over n plus 1 factorial is just going to be 1 over n plus 1, because you can make this a n factorial over n plus 1 times n factorial. These n factorials cancel off, and you're left with the limit as n approaches infinity of 3 over n plus 1. Now, we know as n approaches infinity that this limit will go to 0 because we have that n plus 1 on the bottom. Okay, so 0, that's less than 1. And that means that this is absolutely convergent and therefore convergent by the ratio test. And that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the ratio test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.